Hello everyone, welcome to Join to Learn channel. So as you people have already seen me in shorts that I am going to teach signals and systems in this channel. So let us start now. Coming to this subject, it is very important subject for both triple E and as well as EC people. This subject is considered as base. If you don't know this subject, you can't master in other subjects. That is why signals and systems is a very important subject. It is like a base. Without base you can't build a building, right? Like that, without signals and systems you will not understand many other subjects which you are going to face in the upcoming semesters. So that is why you should pay much attention towards learning this subject. Okay, now without wasting much of time, okay, let me clarify one thing. I hope everyone is having syllabus with them, the semester syllabus which will be provided by your corresponding universities. You will be having that, so I am not writing syllabus again here. Just see the syllabus and follow these lectures properly, then you will be able to understand the concepts in a much clear way. Okay, now let us not waste much of the time. First of all, I have written the name as signals and systems. Before entering into this subject, we should be knowing what is meant by signal. So what is the definition of signal? We are saying signals and systems, so what basically a signal means? So signal is nothing but it is a physical quantity that varies with time, space or any other independent variables. And here we also have examples. Audio is a signal, is a kind of signal, image is a kind of signal, video and etc. These are examples of signals. See, in my way of teaching, first of all I will be dictating the definition. Just by listening to the definition you will not be able to understand the concept in a better way. So what I will do is I will explain this definition by taking an example. Again, after listening to the example you have to go through the definition again, then you will come to know each and every word of this definition. Don't be worried if you don't understand in the first time, if you don't understand in first time. So I will be explaining this definition with an example. So see, in the definition itself, what do we have? I said a word called as independent variables. So what are independent variables? First of all, we should know this. Independent variables are nothing but the variables which do not depend on anything. Like you can see here I have written some examples. Time. So does time depend on anything? So can you stop the time, or is time depending on any of the things? Like is time asking permission for going forward, like that? No, right? So that is why you can't uh, say that time is dependent on so and so thing. So that is why time is an independent variable. In the same way, space. What is a space? Space is nothing but a volume of earth, you can say. So the currently you would be listening to this lecture by sitting in any room. The volume occupied by that room is also a space. In the same way, is space depending on anything? No, right? So the variables which are not depending on anything are known as independent variables. So what do we have to do with these independent variables? Our signal, our physical quantity which will be varying with these independent variables, that physical quantity is known as signal. Even now also some people would have got some 50% of the clarity but not 100%. Let me explain with an example. So in one of the classifications of signals we have 1D signals. Why I am explaining this concept is for you people would be able to understand the definition better by this example. So what are 1D signals? 1D indicates dimension, one dimension signals. Let me write the definition. Signals which vary with only one independent variable. With only one independent variable are known as one-dimensional signals. For example, I am taking a signal known as current signal. I of t is equals to I have some im into sine omega t. You need not to go in details of these things you will be covering in the upcoming lectures. Just what I have to convey you is, like, here there is a signal called as current. You must be knowing, see, this current is depending on time, I of t. So if the time is changing, then obviously the current would be changing. Here we can see the Im into sine omega t. How will you draw that? You will be drawing this signal as like this. In x-axis you have I, in y-axis you have I. So this current is changing with respect to time. At this particular instant of time, the current is high. At this particular instant of time, it is lowest, like it is maximum, it is minimum. At this particular instant of time, it is 0. So in this way, the current is varying with respect to one independent variable known as time. So that is why this current here is known as a one-dimensional signal. So here current is also a physical quantity which is varying with respect to time. That is why you say this current as one-dimensional signal. So in the same way, if I speak about two-dimensional signals, 2D signals, now you people should be able to write the definition. So come on, tell me what's the definition, or write on your own. In the same way, signals which vary with two independent variables are known as two-dimensional signals. For example of these two-dimensional signals is image. See how, let us justify this example. How do you have an image? It will be in this square shape, right? In this shape only you will be having image. An image will be divided into many number of pixels, like, right? You would also be knowing the clarity of image will be measured in terms of dimensions, right? Like how it will be 480 into 720. In this way, what are these dimensions? These are nothing but pixels. This is x-axis, this is y-axis. So an image will be divided into number of pixels. So now you can see that image is dependent on which variable here. See, this image is dependent on independent variable known as space. So some people would get the doubt that you are saying that this image is only dependent on space. Then how come this become a two-dimensional signal, since it is depending only on one independent variable? Yes, I agree, it is depending on only one independent variable, but this one independent variable will only be get further divided into two independent variables. That is what? Space, we would be having many number of axes, right? X-axis we will have, y-axis we will have, z-axis we will have. So far we would have studied only three dimensions, but there are more than three dimensions, like x, y, z, w. In this way we need not go into detail, but as concerned to the image, we only have two dimensions, that is x-axis and y-axis. See, if you consider this is a square box. In this square box, if you consider you are having a your face is present in this in this square box. See, if you are at this point of time, at this point of space, what's the x-axis value? Let's consider like this: 0, 1, 2, 3, 4. Here also 0, 1, 2, 3, 4. So if I consider this particular point, what are these axes? 2, 1. That is x value is 2, y value is 1. At this particular space, what's your image? It would be showing your jaws or something. If I consider this thing, this is nothing but x will be here 2.5 comma y will also be 2.5. At this, what you will be having? Your eyes, right? If you consider this as your face, then here it will be your eyes, here it will be your jaws. See, if I am changing this these two variables, so the image which is known as our signal is also changing. So what you can derive from this, that that our image, our signal is dependent on two independent variables. As you are changing these two independent variables, the signal is also changing. So the value of the signal at this point of time, at this point of space, you are having some value. At this point of space, you are having some other value. See, If you are changing the independent variables, your signal is also getting changed. That is why image is known as two-dimensional signals. Now, one second. Let us talk about 3D signals. We also have 3D signals. Why I am saying these many examples means you have to understand the definition in a better way. What is a 3D signal? You have to write the definition on your own. Signals which would be varying with three independent variables are known as three-dimensional signals. Best example for three-dimensional signals is video. Video is what is a video? So video is nothing but running images, you can say, right? At this point of time, if you are watching a movie, let us consider an example of movie, right? You would be watching movie at particular instant of time, like at what should I say, at 1 minute of time, you would be seeing the face of hero. Okay, at 1 minute 10 seconds of time, then again in movie you would be seeing the face of heroine. So what is hero here? It's an image. Okay, what is heroine? It's also an image. These two are also signals. So what are these things indicating you? At 1 minute it is a time, right? At 1 minute 10 seconds it is also a time. So here we are having three dimensions. What are they? Three dimensions. They are time, x-axis, y-axis of the images, right? When you are changing the time and x-axis and y-axis, then your image will be flowing. Your image will be changing with the flow of time. That is how you are able to see the videos, right? If you consider image, there is no discussion of the time. It will be fixed, right? Even in the 1 minute also, 1 minute 10 seconds also, if you consider image, the image will be constant. In the same way, if you consider video, then it would be depending on one more independent variable known as time. So here the signal video is changing with respect to three independent variables, which are time, x-axis, y-axis. That is why this video is known as three-dimensional signal. Now let us come to the definition again. Now you would be getting a much clear-cut idea on this definition. Signal is a physical quantity that varies with time, space, or any other independent variable. I hope this definition is now clear after explaining these many examples, right? I would like to say one more thing. You have to understand the difference between, wait a moment, function and signal. This is very important for a definition. Function and signal. What's the difference between these two? Many would be saying the signal as function. It's you would be saying signal aka function, also known as function, but that is not true. See, yes, it is partially true, but it is not completely true. Let me you people will be in second semester or third semester, I guess. So if you go into higher studies like M.Tech or if you do PhD in communication systems, then you would be you would be writing a function or drawing a graph for your speech. Now I am telling you some lecture, right? I am delivering you some lecture. I am talking some words. This is my voice signal. Voice signal you will be writing in terms of mathematical equations. F of x is equals to x power 3 plus e power minus 4x. In this way, some kind of function, in some kind of functions you will be writing in your M.Tech or PhD. It won't be in these the functions won't be in this much easier. They will be much high complicated. That is not our point of discussion. I am just telling you, when you go to higher studies, you will be writing these signals in form of mathematical expression. Simply when you don't know the concept of signals, what do you call this as? When you see this, you call this as some mathematical function. You call it as a function. So after knowing the signal, you are calling this as a signal. So I have to clarify one thing here, that a function is not always a signal. Function is not always a signal, but a signal is always a function. So you would have got confused. Let me tell you, if a function, see, this is a mathematical function, okay, fine. So when a mathematical function is indicating or giving some proper information, then only, on this condition only, you would be calling this mathematical function as signal, or else it is a simple function. This is the main difference between a function and signal, which you have to know. So see, like I'd be saying that this function is my speech signal, whatever I am delivering the lecture to you, my audio is varying with respect to x is let me write in terms of t cube e power minus 40. So my speech signal is varying with respect to time in this way, like t cube plus e power minus 40. How you derive this? By using your speech. It is not our point of discussion. It is when you go to higher studies, when you show interest in ECE, then you will come to know all these, how do you write equations for your speech. See, the point which I have to say is, when a function is describing some proper information, this function is let me say that this function is defining my speech, then it is known as signal, or it is simply a function. But a signal, like a speech signal, or a, what do you say, an image signal or video signal, where they all can be written in terms of mathematical functions. That is why a signal is always a function, but a function is not always a signal. It is a function is a signal only when it is conveying some proper information. Yeah, this is it, guys, for this lecture. It is enough. In the upcoming lectures we will see more details of signals. So let me consider this as an introductory lecture for signals and systems. I hope everything is clear. The main thing which I request you people is, maintain your own notes. See, don't maintain your notes like this. You have to frame sentences on your own. Since you are not kids anymore, you have to watch the entire video once, and then after watching the video, then you have to open your notes and write down whatever you have understood in a very proper way, in very proper sentences, in English sentences. Then only you would be able to prepare a notes. Don't follow me, this is not a notes, okay? That's my request. And follow these lectures, and subscribe to our channel for more interesting lectures of subjects like this, okay? Thank you for watching. We'll catch you up in the next video.